that we can record this session. First of all, thank you guys for joining us. Thank you, Paulo, for joining us. I think we have an incredible opportunity here. Every year, for those of you that are new to NGHS, every year during the induction ceremony, usually around that time, you guys get to meet with the speaker and kind of ask them some questions and get some answers from them, because they were not always, but we have with Paulo, a former Bolivar student. And so I always find that it's interesting to see the journey that a student takes from these same seats that you guys are in, not really because you're in your houses, but when you're in those desks in middle school and high school classrooms, and to get where they are now, I always think that journey is incredible for anyone. And so what I'm gonna do, Paulo, to start us off, is I'm gonna kind of just talk through your journey based on your CV, just kind of talk about where you've been. And then I think what you guys should be doing while I'm talking is listening carefully and see if there's anything that connects with something you're interested in, something you might want to ask a question about. And questions don't have to be about necessarily his job. Some of the best questions are about things that he might have experienced in his life to get to where he's at. Does that make sense?
Perfect.
We good? Okay, it's tough at the end of the day. I know you guys are tired, so we're gonna hopefully amp this up with some questions and answers in a second. So we have with us here a CEO and co-founder of FlowFect Technology. Now, I am not going to even try to explain what that is and what you do, Paulo, but I just want to put us at that point already. Now, where did he come from to get to that point? So he did his bachelor's at a little small school near where I grew up in Virginia, Randolph-Macon University, and then went on to do his PhD in bioengineering and biomedical engineering at Virginia Tech. Now, if you guys don't know anything about Virginia, there's something that's really important, which is football and basketball. And Virginia Tech is one of our biggest universities in Virginia, and the University of Virginia, where I went, is one of the other big universities. And we are rivals. So we are the Colombo Britannico and Bolivar rivalry.
You stole my words.
You stole my sports. Words. All right. In sports for universities. And Virginia Tech happens to be one of the greatest engineering schools in the country. So I'm sure he's got a lot of stuff to tell us about in that. And then he did some postdoc work. Was a research scientist. He was even a math teacher, a high school math teacher. So he's had a tremendous amount of experience. And now we end up, you have been at MIT for now 4 years, or are you still there at MIT?
I transitioned to the company.
Okay, so went to MIT. Perfect. So at MIT, is when you started the design of your idea, and now you're at your company, Kytopen Corporation, where he's working on this cool idea that I do not want to explain, that I think will be awesome. So you can see how this trajectory kind of takes us, and we don't know, just from that, we don't know what came in between. We don't know the maybe challenges, successes that he had, the people in his life that shaped him. And so those are areas that I think you guys can get at with some of your questions for Paulo after he gets a chance to kind of intro himself. So Paulo, it's all yours.
Thank you, Mr. Roberts. I appreciate the opportunity to be here sharing my story with you and all of these wonderful students. One thing I would like to do, if possible, if I can get the chance of sharing the screen, that would enable me to just show a couple of images that will make it even more interesting for the students, because I have been in lectures where it's all talk and difficult to visualize it. So we can go with a couple of slides. And so the question at the beginning was, you know, where do I come from, and what have I done? And in many sense, I come from families just like yours. And I actually want to show my family. I want to show my family because for me, my family is the motivation that has allowed me to be far away from them, but that has fueled me over all of these years to strive to make an impact in other people's lives, specifically in the medical field. And here is my family, all the way from my grandparents all the way to my youngest cousins. The picture's not updated. Now I have a young daughter, and we are expecting a baby boy in May. So the family will be growing to 4 of us, and that is really exciting part of our journey. When I was in Colegio Bolivar, a lot of the activities that I was involved in were in regards to playing soccer. I played a lot of soccer while I was at Bolivar, and I really look forward to those games against Colombo. Those were some really good memories. And I was also involved in the summer camps with Sinergia, and I was part of the founding member class. Those were always great summers, just being able to help other individuals that are less fortunate. In terms of schoolwork, the classes that I really enjoyed were more the science related classes. I really enjoyed math, I enjoyed physics, I enjoyed chemistry a lot. And I think that is what has helped me shape part of the journey that I have taken into the work that I'm doing currently. From Colombia, I actually went to Virginia, and in Virginia, I attended a small liberal arts school that's called Randolph-Macon College, close to Richmond, close to one of the main cities in the state. And at this university, what I did is continue my studies in terms of math, pre-med, and also science. So I had a Bachelor of Science in Physics, and the school is Randolph-Macon College. And at that point, I was trying to figure out what type of degree could help me, give me the background that I would need in order to help patients. So that's how life started for me in the US, wanting to pursue those degrees. And at Randolph-Macon, I also played soccer. So I was able to attend that university because I received a scholarship in order to pay for my studies and also attend school and earn a degree that I was pursuing. So scholarship at Randolph-Macon involved in some limited research capacity and really exploring different fields of science in order to shape the future for some opportunities. From Randolph-Macon, I actually transitioned to the southwest part of the state, and the state is called Virginia, in which I went to Virginia Tech. And at Virginia Tech, as you can see on the bottom right, it is well known for its football atmosphere. And this is football, not soccer. This is actually American football, which is what drives a lot of the students to go to this institution, but also the fact that it's a well-known, reputable engineering school that I attended. One of the things that I highlight when I talk about Virginia Tech is that we had Michelle Obama actually give the graduation address in 2012, and that was part of the highlight of the university. By the way, I put this presentation together back in, I believe, 2015, because my family was always asking me, Paulo, what is it that you do? How come you're still in school? When are you going to get a job? And at Virginia Tech, I was doing grad school. So that was the PhD in biomedical engineering. But then I stayed at Virginia Tech doing a postdoc. So after you get your PhD, I stayed 3 more years doing research. And I stayed because the research was fascinating to me we were investigating a way to kill brain tumors using electric fields, using electricity to kill cells. And that was fascinating to me. And so I wanted to share that with you. And also I wanted to share with my family because not everybody really understood what I was working on. And so I'm just gonna give you a quick high level overview of what that work was at Virginia Tech. Specifically, my contribution was to use medical images. And here we're talking about MRIs, and using those MRIs to then do numerical models. Numerical models are a way to do simulations to understand the different parts of the brain, the gray matter, the white matter, the tumor, and understand what level of electric pulses would be needed in order to cover the entire tumor for the treatment, so that then the physicians and the veterinarians could actually treat these patients. That was my PhD work, and that's why I stayed at Virginia Tech, in order to continue advancing those therapies. At Virginia Tech, the other thing that they're well known for is that they have a veterinary school of medicine. And so I was working with neurosurgeons, helping them with the treatment planning. The neurosurgeons were introducing these electrodes into the brain and delivering some electric pulses. 90 seconds of electric pulses was sufficient to kill tumors in the brain. And we were able to demonstrate that in some canine patients that were people's pets that would develop spontaneous tumors, and that we were able to cure with just 90 seconds of electric pulses. And that's what we're showing here. This is one of the patients that we treated. Lena is the name of this pet. And we completely eradicated the tumor from the brain with just 90 seconds of pulses. So this opened up, the field for me, and I was amazed as to what engineering could do in medicine. And so I continued my journey along to a different part of the country. I went from the middle of the country, Virginia. I went to the Northeast, which is the Boston area. And that's where I am right now. I am in Massachusetts, that's the state. And specifically, I went to MIT. At MIT, there was an opportunity to do another postdoc. And again, my family kept asking me, when are you gonna start working? Why are you still in school? And I said, I'm working, I'm getting paid to do this, but it's research in order to advance a particular technology to impact biotechnology or patients' lives. And it was at MIT that I learned some more about microfluidics, so fluid flows and electric fields, in order to manipulate cells. And so when I talk about manipulate cells, here I'm gonna jump into where I am right now. The company that I founded in 2017 is called Kytopen, and I co-founded it with my co-founder, Colin Buey, who was my professor at MIT right here. We were one of the first 7 companies to join this new space that MIT created. And the reason why I started a company and why we are working on the project that we're working is specifically to help patients such as Emily Whitehead that at some point were suffering from leukemia and some other blood cancers. And through the technology that we are developing, we are able to engineer cells of patients such as Emily Whitehead in order for those cells to go back into the patient and treat cancer, to identify the cells that are malignant, kill them, and heal patients such as Emily. I wasn't involved in Emily's treatment. She has been cancer-free now for more than 8 years, but she was the first patient that was treated with a new type of medicine that's called cell therapies or engineered cell therapies. So what I'll do is I'll walk you through what the process is. An engineered cell therapy, and the most famous of these therapies is called a CAR T cell therapy, is when the cells of a patient, and these are immune cells such as T cells or stem cells, they are collected. They are collected such as when you go to the doctor and you get a blood draw. That blood is then shipped to a location in which they get manipulated. And they get manipulated by separating the red blood cells from the white blood cells. They get activated so that you can expand them and generate more of those cells. Then they get manipulated by introducing genetic material into the cells so that those cells can gain the ability to recognize cancer cells. And eventually they go back into the patient as a living medicine. That is what this is called. Cell therapies are basically living medicines that are made with your own cells so that when they go back into the body, they don't get rejected. And the exciting part of this journey is that we are now developing equipment to help the challenges of the cell therapies. And that piece of equipment that I'm describing is now shown on the screen. This is where we have the ability to introduce the cells from a patient on the left side. They get processed through a flow cell in the middle, and then the output, what is on the bag, on the outlet, are the engineered cells that will have the capability of helping patients. We're doing this in collaboration with therapeutic companies. We're not a therapeutic company, but a lot of the lessons that I learned along the way, and here are the cells flowing through our devices. They get exposed to electric fields, similar to the ones that I used at Virginia Tech. And then they go directly into recovery media, which is where the cells can actually heal and then be ready for going into a patient. That's the technology that we are developing at Kytopen in my company. We're combining electric fields with fluid flow in order to be gentle to the cells and enable those cells to help patients suffering from different diseases. Just to give you a very quick snapshot, we can process many different types of cells. So stem cells are one of them, but also B cell, T cells, monocytes, macrophages, and these are all cells that can fight cancer, both blood cancers and also solid tumors. They can fight infectious disease, and they can fight genetic disorders. So we're excited to continue along this journey at the end of the day to be able to help patients fight disease with their own cells that have gained capabilities to treat them. And that is really the motivation that I have. We have ambitious plans for this year, but more importantly, the goal is that in 2022, so around a year from now, we will be treating the first humans with engineered cells that use our technology so that we can help those patients. And that's what I strive for every day. That's what the team that we have assembled is also doing. And it's the mission that we are embarking on. And this mission really started when I was in your shoes. It started while I was at Colegio Bolivar and gaining an education and learning about the world and getting exposed to, some of these cool things that are happening other parts of the world that you can also be a part of. So I will stop right there, and I'm happy to take any questions that you may have from any of the projects or any of the journey along the way, including whatever you want. Just go ahead. And if I don't hear questions, I might start calling on people. So I don't know. Carolina.
Hi, Paulo.
Hello.
Very interesting what you do. It's different hearing it from you than reading the website. I was obviously reading the website and your curriculum, but well, thank you for being here. Paulo, what made you, what triggered you to choose like science and in that field? What was the trigger? ¿Qué fue lo que sentiste y por qué pensaste que eso era lo tuyo?
Part of it was that I really enjoyed it. I really enjoyed what I was doing in school, in middle school, in high school. And the fact that I enjoyed it made me want to explore in different ways that it could impact, that it could make impact. But when I was your age, I actually did not know what that impact could be. All I knew was that I enjoyed it and that I wanted to learn more about it. It was really in undergrad when I was at Randolph-Macon that I started looking at what an engineering degree could be used for. And in exploring different graduate programs, I discovered that there was this field of biomedical engineering. I didn't know biomedical engineering was a discipline. I always thought of engineering as either mechanical. My father was a mechanical engineer. My mother is a lab technician or bacteriologa. And so from both of those sides, I could see the science and I could see the engineering, but I never knew that they could actually work together. When I discovered the biomedical engineering program, and specifically that there was an opportunity to maybe impact brain cancer, which I lost my grandfather to, then I started putting the pieces together. So it's part background, it's part being exposed to opportunities like this, because right now, all of you should know that biomedical engineering exists, and then maybe just you can Google it and see what it's all about. And then there's classes that can help you understand the field better. And so I think it was a combination of my parents' disciplines, but also when I was looking to go to medical school, I learned that there was actually a way to impact other patients through engineering, and that was really fascinating to me.
Thank you.
Hey, Paulo, we have a question from Iñaki. Iñaki, you want to ask your question?
Yeah, I have a question. I have to be
Great.
like here close to my computer though. Can I ask that question?
Yeah, go ahead.
That I think it's interesting what you said because I thought that I knew that you could like help cells regenerate with like other cells, but I didn't know that you could like kill cells with other cells.
Yeah, no, there's a significant amount of applications that either electric fields or other disciplines can have in cells. So you can kill cells if they're malignant cells, and that's what you're trying to do when you're treating a tumor. But with the advances in genetics, and many of you might know this, but the Nobel Prize in chemistry this year or last year was for the discovery of CRISPR. That is a way to modify the genetics of a cell. And the field in general is trying to do this so that they can treat diseases better, so that they can improve the outcome for patients. And that is being discovered with technologies such as the one that we are developing to facilitate the introduction of that genetic material into cells. And so yes, a lot of very, very exciting applications, including treatment of diseases with just cells that can be transplanted from one patient to the next.
Hey, Paulo, when you first left Bolivar, what do you think one of your biggest challenges was? And it might not have been immediately. And what did you do to overcome that challenge?
Yeah, so there was a couple. There was a couple because I actually left my senior year in high school, and I went to a boarding school before I went to Randolph-Macon. And at that boarding school, I was, by myself. My family was back in Colombia. I was there living with other students. So I had a roommate from South Korea. We became really good friends. And one of the challenges that I overcame was sometimes I was a little bit scared of speaking in English. I was a little bit intimidated by these native speakers that could speak really fast. They could speak really fast, and sometimes I would have trouble understanding. And so that was a little scary, no doubt. And as I spend more and more time with these individuals in Virginia, I learned to understand them better, and I was able to speak with more confidence. So that is one of the challenges that I had early on. Not because I didn't know English. I mean, the school prepared me tremendously well, but because of the speed at which it was being spoken, what was a little bit challenging. So that was one of the things, and being homesick was also one of the things that was challenging for me, specifically being in Colombia with my family, with my sister. And so the way to overcome that one was, my brother was already in Virginia at a different university. He was at William and Mary, which you likely know about. And so every so often I had the chance to go and visit him, and that also helped with the homesickness. So I was very homesick, particularly at the beginning. And I think the last one that I'll share with you was the weather. The weather during the winter was really challenging. It gets really cold, really cold. And so I was wearing a large number of jackets in order to stay warm. And now actually I barely wear a jacket here in Boston in the winter. So you can adapt. Basically, the take-home message here is, at the beginning is shocking, but with time you can adapt, and your body actually tells you, don't wear so many jackets. You don't need them. So good question.
Awesome.
Oh.
Nikki has a question.
How did you start?
How did I start? How did I start? Nikki, how did I start? What aspect of?
Like, how did you start everything you did? Like, where did you begin?
Okay, let me see if I can answer that one. Where did I start? I generally start things by just trying to understand them as much as I can, because in many cases I don't have the answers, and so I generally start by asking questions, by understanding what others are doing, and then trying to formulate my own plans or my own wishes. For example, for Virginia Tech, where I started was in just reading a bunch of papers, a bunch of scientific literature to see what others had done, and then making my own ideas, and then sharing those ideas with supervisors, with other researchers, to see if the plan that I was constructing made sense. For the company, where I started was in trying to engineer bacteria. We were engineering bacteria for a completely different application. Having those E. coli actually produce chemicals. That's where we started. But then people started asking us, can you process mammalian cells? can you do anything in T cells? And we hadn't. We had not done any of those other applications. And so that where we started there was, let's learn about these other cells that seem to be very popular, that seem to be doing some good in the world. And so we started not only asking questions, but also hiring people that knew a lot more than we did in terms of that biology. And that's where that one started. And so in general, really, we start by acknowledging that we don't know, that we don't have all the answers, and talking to those that actually have that information so that we can better understand, and then put our own spin, put our own ability to improve it or change it so that we continue developing a particular process. So that's how I start.
Paulo, my name is Tim Kennedy. I'm a math teacher here in the 7th grade. This group, first of all, your story is very impressive, and what you've been able to do, and I salute you for that. But we're in a group of kids here. These kids here are all high achievers. They're all academically very sound. They're hard workers. They're nice kids. Do you have any advice for them in order to navigate through high school and 8th grade for some of them? And then the second question is, do you have a teacher that really changed your, just changed you as a person and you remember back in the day?
Thank you, Mr. Kennedy. Great questions, all of them. So I'll start with navigating through high school. And one of the things that I think I was successful at was to be able to enjoy high school, but also make sure that we continue developing the academic skills for the particular interest that I had. And what I'm saying by that is enjoying the journey, but making sure that you're paying attention to your studies. I think first and foremost is one of the recommendations that I give to all of you and all of those other students that I engage with in a mentorship capacity, because there's going to be a lot of distractions or a lot of temptations, and at the end of the day, you are the only one that can control your destiny, and staying true to what you like to do, and some of the studies that you want to pursue after high school are what's going to stay true to yourself. I lost my father when I was in 4th grade, and that meant that it was my older brother Charlie, my younger sister Stephanie, and my mom, and we relied on each other tremendously. I think that was one of the hard things about my life that I had to deal with, and that meant that I had to become very independent because my mother was working several jobs in order to help us remain at Colegio Bolivar, even with all the assistance that we were getting from many of my friends' parents. One of the things that during that time frame, I connected with several different of my teachers, and so I remember fondly Miss Vera is one of those individuals, and Miss Carolyn Field is another one. I remember Manuelita very well in chemistry, Mr. Bouchard as well. So there are several different professors, teachers that helped me through that journey, and that also enable me to be successful not only in high school, but certainly in undergrad when I was taking organic chemistry again. And everybody will tell you organic chemistry is the hardest class ever, but not if you have taken it with teachers that are of the caliber as Manuelita, because it was a really, really well taught class, and it opened doors for me in the future. Same with physics, for example. And so, many, many fond memories of the school. The quality of the education at Colegio Bolivar is phenomenal. And really what I would do is I would just challenge you to take some of those courses that may sound like they're very challenging, because they will actually prepare you for the future uh, plans or endeavors that you embark on.
Ciao.
Yep.
Sophia, you're up.
Okay, so I have two questions. The first one is, I was wondering if these treatments have like any side effects or something. And the second one is like, what hopes and expectations or like what effects do you want this company to have in the future?
Great questions. If we talk about the initial question, side effects, and if you're talking about the treatment from my graduate studies, so brain tumors, those electric fields have the capability of killing tissue, because we are using electricity to directly kill the tumors. So if the placement of the electrodes is not accurate, if you put it in healthy tissue, then it also has the ability to kill healthy tissue. And that's why the treatment plan and doing the placement of the electrodes so carefully was very important. And that's why we did it with neurosurgeons that had that expertise. In terms of side effects of the treatments that are being conducted with cell therapies, there are some side effects as well, particularly if the cells that are engineered, for example, are being given to a different patient, not the same cells from the individual. And that's where the field is being very careful to make sure that all of the tests are being done to prevent side effects. But these are some very strong treatments. If you think about it, you're battling a cancer, and cancer can be very smart. Those cells can mutate and evade any treatments, and because of that, the way that these cells or the testing needs to happen, it's pretty involved, so that those agencies that approve these treatments are confident that it will help. But it at the beginning, for example, when they're trying to determine the right dose, they keep the patients in the hospital just to make sure that everything goes well. Hopes and aspirations or expectations for me are many, but specifically these types of therapies right now, the ones that are approved, they cost on the order of $500,000 to $1 million. They are extremely expensive. And that means that not everybody can have access to these therapies. That is using the standard of care or the state of the art. The hope is that with technologies such as the flow effect technology, that we can significantly reduce the cost of manufacturing those cell therapies, so that many more patients can actually use it, get access to it, and more importantly, get cured. The hope is to be able to open up opportunities with the cell therapies to treat diseases that currently do not have a cure. And that is what is the most motivational for me in terms of going into, I don't consider it work, but going it into work and working on this technology development. Great questions.
Connie, you're up.
Yeah. So before you said that you were like scared of going into this new environment with like a new weather and new people and all of that, but I was wondering if you were scared of like the decision that you made of going after that path of like science and medicine and all of that. So like, weren't you scared that you had made the wrong decision, or like later on you were gonna regret it and you were gonna say like, why did I choose this and all of that. So what were your feelings in that?
I was terrified. I was very scared to go to the US and embark in this journey because of what I call the fear of the unknown. And this fear is there on multiple occasions. I've had that same feeling when I started undergrad. I had that same feeling when I moved to Boston. I had the same feeling when I started a company, specifically because it's an unknown. You don't know what's going to happen. You think it's the right decision. You don't know what's going to happen. And but what I'm happy to tell you is that in every one of those occasions, as I learned about what I was jumping into, as I experienced it, that fear gets reduced a little bit and a little bit because you get more comfortable, and you also start thinking about how can I make sure that this new and exciting experience will be productive, it will be beneficial for you, for your family, for those around you. But every single time that I have made a decision like that, I have been terrified, no doubt.
Great question. Iñaki, you had another question?
Yeah, my question isn't directly related to you or your job, but it's related to like your knowledge about cancer. That
Okay.
like because I have heard some interesting facts that I have heard, but I'm not sure they are true. I want to know if you could confirm them. For
Oof.
example,
Ah,
here's
Go
one.
ahead.
Why do big organisms get less cancer when they should get more?
Great question. I'm going to say that I cannot confirm that question in terms of larger animals getting that they should be getting more cancer. One of the things that was interesting to me that I learned when I was at Virginia Tech was that dogs, and specifically the breeds that are called brachiocephalic, which means the ones that have the flat face, like a boxer, for example, or a pit bull, they tend to get more cancer than other types of breeds. And what I learned is that the brain tumors that these canine patients were getting, it's very representative to the ones that humans actually get in the brain. In many cases, if it's environmentally related, we share the same environment as some of our pets. Uh, but Iñaki, the truth is I don't know about the question that you're asking me, and if larger animals should be getting more or less. I'm not familiar with that. And maybe
Okay.
this is a good other lesson for all of you, in that in many cases we will not have the answers, and saying I don't know is completely okay. It's completely okay, and then looking it up or learning about it, and then getting back to the individual that asked you the question, that is a completely acceptable approach. So don't always think that you need to have all the answers. It's okay to not know, and acknowledge that you don't have the answer.
Perfect. Tomas, Iñaki, do you have another question, or are you good on that one?
No, it's a little comment that if I can send a video that talks about like that topic.
That would be great.
Just pop it in the chat, and then we're going to go with Tomas and Antonia are going to ask another question.
Yeah, so what was your greatest?
We can barely hear you, Tomas. Your volume's really low.
Wait, I'm going to try to connect again.
Still low. Still really low.
Tomas, if you're speaking to us, you might be muted right now.
think he's probably trying to resolve his audio. I found it interesting, Paulo, what you said to Iñaki, because I think this is interesting that oftentimes students are, especially this age, have a lot of information at their hands and they want the answers. And I think this generation of students is going to be the ones to find these answers, you know, with the rate at which technology is improving. And you guys are a testament to that.
Absolutely.
That is the way. Let's go to Antonia while Tomas resolves his audio.
So I don't know if somebody asked you this question already since my internet kicked me out, but
No
my
worries,
question,
go ahead.
so my question was that if you ever like in your life consider like a different career choice, or while you were making the decisions that you were making, did you ever regret making like choosing that career, or you always loved it?
That's a very good question. And I had a tough time identifying which career to pursue early on. And I was sharing a little bit that my mother was coming from a science background, my father from a technical or engineering background. And when I was in undergrad, I was considering either, you know, civil engineering or medical school. Those were the two types of disciplines that I was looking at. And I was preparing for either. That's why I was doing pre-med, but I was also doing physics and math. In doing research as to programs for medical school, I discovered that there was a way for the medical school to fund your degree, because medical school could be really expensive, but you had to get a degree along the way. And one of the options that they provided was biomedical engineering. And so I started looking at that program, and I learned that biomedical engineering was going to be a funded program. So I was going to be able to go to school and get a stipend and use engineering and biology together, which were the two disciplines that I was looking at. Since I did that degree, I haven't regretted it a single day, specifically because I'm on a path towards trying to help patients. But in general, the way I look at life is there's always opportunities to explore other fields if you haven't had the chance, and that everything that you do learn some things, and it builds who you are. So from that perspective, there will be other opportunities. Let's say if I wanted to go into arts or something like that, that it can be done in the future. And I don't see life as, if I didn't do it in that particular moment, I missed my chance, because there will be other opportunities as well. But it's a really good question, and I landed on biomedical engineering after exploring purely engineering discipline and purely medicine in isolation.
Thank you.
Thank you.
Tomas, is your mic working now?
Can you hear me?
We can hear you very well.
Perfect. Yeah, sorry. So my question was, what was your biggest challenge as a foreign entrepreneur in America? Like, you were already in a disadvantage for not being American, and starting a business, like, I can imagine that it is very, very hard. So what was like the breaking point where you could like make it through? Do you know what I'm talking about?
I think I partially understand the question, and so I'll take a stab at it, and then feel free to follow up. One of the things that I will say is that I have been very blessed for not only being able to start a company now, but I started one earlier on when I was at Virginia Tech as well. So this is my second company that I am involved in. And the challenge is, maybe in my case, not necessarily related to not being an American. It's more that the burden of proof or what investors want to see and what collaborators want to see, it's very high. They want to see proof that what you are developing will work. And a startup, by definition, it's in the search of trying to generate that impact and in the search of demonstrating that there are some very large opportunities to develop something that will impact either patients or whatever field you're in. So from my point of view, it's been more convincing investors and therapeutic partners that we are on the path towards something huge. And I've been very lucky to have some good mentors, some great co-founders that can help in the validation. But you're right, starting a company is one of the hardest things I have done in my life. And this one in particular is shaping up nicely, specifically because of the work that we did at MIT and the potential impact that it has. But there's still a lot of challenges in starting a business from the ground and navigating everything that goes around it, including technology development, managing individuals, raising money. All of these things are things that keep me up at night, and Carolina knows because she has tried to reach me in many occasions, and it takes me a while to get back. But I haven't experienced the big challenge because of not being a U.S. citizen. I'm a permanent resident right now, but in my first company, I wasn't, and we formed the right team. We formed the right team with the right idea, and that helps tremendously. But that's my case.
I see. Thank you.
Thank you, Thomas.
Any other questions?
Yeah, I got a question, Mr. Roberts.
Sure.
Paulo, first off, thank you for the work you do. You're a hero in my book. Having lost loved ones to cancers and
Yeah.
Going through that process, knowing that doctors had told me a couple of years ago, as my mom was going through it, chemo and radiation, we're not going to use this. In the future, like that's going to be kind of outdated, right? We'll have new means and different ways. Is there a certain cancer that you're kind of using this stem modification? Is there certain cancers that you're looking at first, like blood cancers or?
Yeah, so there's some approved therapies right now, and Kite has one, Novartis has another one. They are specifically around blood cancers. These are lymphomas, leukemias, and there are other companies such as Vertex and CRISPR Therapeutics that are demonstrating curative potential in genetic diseases such as sickle cell disease and beta thalassemia, for example. So these are very large companies that are really paving the way for the this new generation of medicine. With that said, blood cancers are only 20% of the cancers that exist. And so now there's a big push and effort in the scientific community to tackle the other 80% of the cancers, which are the solid tumors. And specifically, the field is going after colon cancer, breast cancer, lung cancer with these types of therapies, and with some early indications that there will be successful treatments, but they are not as far along as the initial blood cancers. And the reason for that is blood cancers are easier to access because they're floating on the blood. A solid tumor, it's difficult to get those cells to penetrate, to be able to completely eradicate those cells. But there are some cells that do live in there, such as the macrophages. And that's why having a way to engineer multiple types of cells will be promising. And my goal is really to eradicate all types of cancers with the therapeutic partners, because we have an enabling platform to help the partners in that manner. And when it's going to be complete for me is when an engineered cell therapy with the flow effect technology cures a brain tumor, because that's going to be the merging of my entire life, and where it all started with my grandfather. So, stay tuned for that. Is something that I have in the back of my mind always. But there is some really, really, really high hope for these therapies to make a disruptive impact, and be able to mitigate a lot of the challenges that are associated with a chemotherapy or some of the other treatments that are could be effective, but that they have some significant side effects. So that's where I spend my time.
Any other questions, guys? Silence is deafening. All right. Well, thank you so much, Paulo. This has been awesome. Great opportunity to connect with our current NJHS students. I think they had some really great questions, and I think hopefully you guys are coming away from this conversation with a little bit more understanding of potential possibilities of where you guys can go after Bolivar. But as he said, requires a focus to your studies, which you guys are already experts at. Naira had a question about
always reaching for a small world story.
if you knew a former student of hers that was at MIT.
So his name is Victor Lushnevsky. It was a good while ago, so you may or may not know him. He was also he also majored in biomedical engineering as well. So
nice. No, I don't know Victor, but if he is around, feel free to connect me with him. And I'm always fond of meeting other folks and expanding my network.
One last question.
Go ahead.
Paulo, do you still keep in touch with your classmates, with your friends? Do you have a chat, a WhatsApp group, or yeah?
We do. Yeah, we have a WhatsApp group. And for example, today we're celebrating a birthday of one of our classmates who lives in London. And absolutely, so we do keep in touch. The Bolivar friends are some of my closest friends. I have friends from other places, but the closest ones were made at Bolivar. I mean, we spent 14 years together, and that is very special. So make sure you remain in touch and develop those close friendships, because they will last a lifetime. Thank you all for the opportunity to chat with you. Happy to take any follow-up questions at any point. You have my contact information, and it's really exciting to see you here. And I'm excited for the future that you will enable, because that is really what it's all about, and that is what I think that Colegio Bolivar can enable you to do. So keep at it, and here for you in anything you need.
Thanks a lot, Paulo. Really appreciate it.
Great.
Thank you, Pablo.
Thank you.
Thank you,
Thank
Paulo.
you.
Thank you.
so much,
Bye.
Paulo.
Bye.